Greetings, colleagues! This is a new format that I decided I would like to record my devlogs in, and today I will be telling you about a thing that I myself have learned existed only a few days ago, the finite state machine. Finite state machine sounds cool and complex. So what is it? Simply put, finite state machine is an abstract machine that consists of some amount of states. These states have transitions between each other, and this machine can only be in one state at one given time, which means that, you guessed it, it's perfect for coding video game character logic. Any video game character can only be in one state at one given moment. A video game character can either be running, or walking, or standing, or attacking, or dying. So, everything fits. So naturally, I decided to use finite state machines in my video game, The Opera Ghost Love Story. Let's take a look at it and see how we can implement the finite state machines in this particular project. So first of all, let's open Godot Engine and GitHub. GitHub is an extremely useful tool for anybody who works with any amount of code. So naturally, I'm also using it to keep up a backup of my files and to be able to work on my game from whatever machine as long as it has an internet connection. It takes a second to load. There we go. What you see on the screen right now is my character script, which answers for every single character in the game aside from the main character. But we'll take a look at it at another time. For now, we will be changing the main character script, eric.gd. But before we do anything here, we need to create a new script, a state script, which is going to be the script inherited by all states that we create henceforth. There we go. So first thing that we're going to do is declare class. The class name is going to be state. All these unnecessary comments are to be deleted. Next, we will write some virtual functions. Virtual functions are functions that are meant to be overwritten by classes that inherit this class. So these will be empty and merely contain the keyword pass. Let's write some. Well, first of all, we will need a function that will update on every frame, and that in Godot is the process function. But here we will call it update instead. Adding the delta argument. There we go. Next, we will need a similar function, but for physics process. Hereby, one needs to remember the difference between the process and the physics process functions. Process updates every single frame as soon as possible, while physics process updates at regular delta intervals, which makes it perfect for calculating physics body states and variables. Next, we will need a function that will handle input. This one will have an input event passed as its argument. And finally, we will need functions that will execute upon entering and exiting the state. The enter function will have an argument parsed a dictionary called MSG, short for message. We will use it to pass data to the enter function. And finally, the exit function. Next, we will need to create a state machine script. State machine will be a script that will handle all actual transitions between the states, and it will also initialize the standard or default state upon first loading the scene. Let's declare its class name. It will, of course, be state machine. Next, we need to write a signal called transitioned, which will be emitted every time a state transitions to another state. And we will also need an exported variable called initial state. we export it so that we could define the default state in the inspector to the right. Next, we will need a variable called state, which default value will be the initial state that we choose. Next, we need to change the ready function. First of all, we will add a yield function, which means that the state machine will only launch when its owner is ready. And its owner is, of course, any character that we attach the script to. Next, we will create a loop that goes through all the children of the state machine node, and we tell the children that they belong to this state machine. And then we enter the initial state. Next, we will write a function that will handle unhandled input. It basically means that any functions that are related to nodes that are called by the engine will be handled by these states. And next, we will need to connect the update and the physics update functions that we wrote in the state.gd to the process and the physics process functions in the state machine script. Which means that we will just define the process and the physics process functions within the state machine and call the update and the physics update functions from the states. And lastly, we will add a transition to function. The most interesting function, in my opinion, really. It has the target state name and the message dictionary passed as its arguments. So first of all, we will add an if check, which will make sure that if there is no target state as a child of this particular state machine, then the function will simply end. Next, we will call the exit function of the current state. Next, we will change the current state to the target state. And lastly, we will call the enter function of the state. And of course, we must also emit the transitioned signal. Perfection. The next part literally took me 55 minutes, so the footage will be sped up. Here, I decided to change my folder structure a bit and add a states folder to the Eric folder. Next, I create the first state, which we will be programming the idle state. And finally, I close all the unneeded scripts to clear up my workspace. And finally, after deleting all the default stuff, we can get to programming. While I clean up, I'd like to clarify why I need the finite state machine in my project at all. Why waste time on something like this, on redoing what is already done? Simple. Finite state machines are irreplaceable in large projects with a large amount of states. Now imagine, each character in my game can have more than 10 reactions to the player at the minimum. Aside from reactions, there is also working, running, panicking, fainting, etc. All of these are states. Using the finite state machine, I can A. Separate the code of these states into clear and cut separate scripts that are very, very comfortable to work with. And B, most importantly, reuse states for different characters. This will literally be so useful going forward. So with that out of the way, let's dive in. So first of all, I copy-pasted everything that we wrote in the state class to the idle class. And then I moved the enter function to the top. It's more comfortable that way. Next, of course, since this is the idle state, then we must ensure that the owner's velocity is 0, which basically means that they're stationary. And next, I will find the idle code that I wrote for the error class and copy-paste it into the idle state class. Oh boy, do I have a lot of garbage here. This is one of the main advantages of doing something like this. You get to rake all through your old code and fix all the mistakes, and also clean up all the garbage. So next, we will handle the transitions to the walk state, which means that I yet again go to the Eric script and copy-paste the inputs necessary to, well, get the character to start walking into the update function. The update function will listen to the inputs from the keyboard and transition to the walk state whenever a button is pressed. So naturally, this calls for a creation of the walk state script, where yet again I do all the same. I copy paste everything from the idle state script and then go to the error script to search for the code that I already wrote. But then I notice that in the idle script, this line is giving me an error. And then I realize that I forgot to instantialize the state machine variable in the initial state script. Oh, silly me. With this fixed, we can now continue working on the walk script. So here I'm trying to program the transitions between the walk state and the idle state, and then I decide, damn it all, I need another state class, a player state class that will be only used by the player node. This player state class has all the same functions that the state class has, but it has a few additional variables. For example, it has variables for animation state machines that the player node uses to handle animations, both for the original sprite and the glowing eyes that Eric has. Since glowing eyes can appear and disappear in various environments, they have to be a separate object and they have to use a separate animation state machine, which we need to reference. I also added a states enumeration variable to the Eric script, which will contain all states that Eric will have in the future, and in the ready function of the player state, we ensure that the parent of the player state is the actual player. So many errors. Not to fret. Next, of course, we make the idle and the walk scripts extend the player state instead of just the state. Let's continue working. So here I'm struggling to make the code that was written by me to work in the state script. It uses a lot of variables that are unique to the Eric script and are inaccessible from the walk script. At least for the state machines, I decided to get a reference to the player node and simply refer to the state machines through that. But all the other variables like eye and lot and smooth have left me with quite a puzzle what to do with them. Frankly put, I decided they needed to be scrambled. But right now, I'm still unsure about that. So instead, I decided to work on the implementation of the movement itself, and also the flipping of the sprites when moving from left to right. I added functions that flip the sprite depending on the direction the player's headed in. Next, I decided that it was a good time to clean up the Eric script, deleting the moving right and moving left functions, and just replacing them with pass. Also, I deleted the idle function and fully commented the inventory function and the process function because they were moved to the corresponding states. And here I continue to follow the GDQuest tutorial that I initially picked and write out the actual movement in the update function of the walk state. Next, I encountered this pesky error. The walk script wasn't seeing the player variable that it was supposed to be inheriting from the player state script. Turns out that the reason for that was that the player variable wasn't onReady. As soon as I initialized it as an onReady variable, the error went away. And here I finally clean up the update function of the walk script, deleting all those variables that were giving me problems earlier. And finally, here's the end result. Let's break it down. So firstly, we see what direction the player is moving in and multiply the player's speed by that amount so that the character would move in that direction. Next, we have the code for the correct flipping of the sprites, and finally, the code that transitions the animation state machines to the walking animation. And here I'm beginning to do another very important thing, which is optimizing the code. I transfer the lines of code related to the state machines from the update function to the enter function, because they don't need to be executed every single frame. You launch the animation once, and that's it. And here I utilize a bit of simple math logic in order to further optimize the code. Instead of checking 2 times whether the sprite scale is positive or negative to see if it needs to be turned into the opposite direction, I do one check, which multiplies the sprite scale by the input direction and sees if that is more than 0. A lot of code can be optimized in this way. I suggest you look out for things like these in your own code. The last preparations before the first bout of testing. We're going to add the state machine and the 2 states that we wrote as nodes to the kinematic body 2D. And of course, we will attach their scripts to them. Now, the moment of truth, we put what we wrote to the test and launch the game. As expected, nothing works. The character isn't responding to my controls. Let's figure out why. In the end, I decided to create a player-specific state machine class, the player state machine, just like I created a player-specific state class, the player state. I change the type of the node that is attached to the kinematic body to player state machine and reattach the needed script. Next thing, I make sure that I can reference the player state machine from the Eric script. Since its name is in conflict with the animation state machines, I delete those. Finally, time for second launch. This one was curious. I've never seen such an error before, and so I decided to do the obvious thing and Google it. I simply copy-paste the error into Google and click on the first result. In the next 5 minutes, I pretend to understand whatever is written on this page with a very important expression on my face. I see something about static typing and realize that it probably means that I shouldn't define the type of the state machine in the erg.gd class, so I go ahead and delete it. Time for yet another test. Well, this one's weird. Why is the player state machine not found? I attached it to Eric myself. I checked the node list and it's not there. What's going on? In an attempt to understand what is wrong, I open up the Safi Abad hallway scene that launches in the very beginning of the game. And I realize that it doesn't use the Eric scene that I have been modifying. So of course it wouldn't have the player state machine attached to it. I quickly remedy the error by attaching the player state machine and the states to it, just by copy-pasting the nodes. As I do so, I think, why in the world doesn't the scene use the Eric scene that is supposed to be used throughout all of the tutorial? And then I realized that it lacks some of the buttons. Well, it seems like I just wanted to turn off some of the controls. That is insanely dumb, I thought, and quickly rectified the error by first making sure that Sophiabad Hallway doesn't have any unique nodes, and then putting the Eric tutorial scene into the Sophiabad Hallway scene as it was always supposed to be. Then I go to the Sophiabad Hallway script and hide the buttons via code. Like, once again, it was supposed to be from the very beginning. So now that we actually have the player state machine in the scene, let's try another launch. Okay, why is it telling me that the state is null? It's supposed to be idle. What the hell? And then I realized that I forgot to actually pick the initial state in the inspector window to the right. Right. Another launch. Hmm. But of course, now player.stateMachine refers to the player state machine that we have just coded in, not the animation state machine that I meant to refer to here. So we're just going to change the names and launch the thing again. Wait, why does it say that animation state machines are null? Oh, maybe they didn't get defined somewhere. But of course, let's uncomment these lines of code and try another time. Well, what is wrong now? Maybe I need to define them in the player state machine class. Let's try that. Well, maybe I need to define the animation state machines within the player state class and not the player state machine. Let's try that. Hopefully it works. At last, it works. It works. One cannot overstate the joy that you feel upon finally getting it to work. Now, literally everything that we have to do is to tweak the speeds a little bit, and we have the final result. I, for one, am incredibly satisfied with how this went. Hopefully, you found this enjoyable, and if you are a programmer yourself, hopefully you also found something useful in this video. Thank you for watching, and I will see you in the next video.